Hello friends, today we are finding the value of electric potential due to an electric dipole. This is our part of electrostatics. Let's start. So we have a dipole, that is which we are considering, which is nothing but AB. Okay, so I have A point, we have B point. That means we have the charges like minus Q and plus Q. At point A we have minus Q, at point B we have plus Q. They are separated by finite distance, which is nothing but it is 2L. Okay, so now I am taking a point, the AB, which is the line which is going from this two dipole, is nothing but it is my dipole axis. I am taking a center point O here, and my P point, which is outside that dipole, they are separated by distance which is nothing but R. Okay, so now we have AO is L and OB also L. I am line joining from here, that is AP and BP. Okay, I am doing a construction like I am extending my PO at point A dash. Okay, and the line joining from the A to A dash here, I am doing the same perpendicular line from the B towards the OP, so I will get the B dash here. So when the perpendicular line which is perpendicular to that base, it gives the 90 degree. So here we have the 90 degree. That means when the PO, when the line which is joining, we get the angle theta here. So similar angle theta is here now. So we have to know that what is the dipole, electric dipole, or we know that we have the two charges, that means it gives the dipole, and we have the dipole moment which is nothing but it is a P, which is equal to Q into 2L. Okay, so now we have the charges, we have the finite distance, that is 2L. Now we have to determine the electric potential due to the dipole of the origin at point center O now. Okay, let's start. We are starting point from the A point, so we have AP dash now. So what is my AP dash? I have AP, sorry, I have to find out the AP, which is approximately equal to A dash P. Look at the A dash P from this figure. We have A dash P here. So we are considering A dash P, which is equal to AP, because we know that we have OP's small value like R, and here we are seeing that AP is greater than R. Okay, that's why we are extending, or we are doing the construction, we are extending O A dash or A dash O. So now we are considering AP, which is approximately A dash P. Okay, so A dash P is nothing but it is a combination of A dash O plus OP. Look at the figure again. So we have A dash O plus OP is nothing but A dash P. We know that it is our linear points, collinear points. So we know that value of OP is R. So we are taking that value R. So we have to find out the A dash O now. So that means we don't know about the value of this. Okay, so we are finding. Look at this term. A dash O is our adjacent term. So we get that value due to because of cos theta. So cos theta, which is nothing but adjacent upon hypotenuse. So what is my adjacent term here? Adjacent term is my angle is here. So adjacent term is A dash O upon hypotenuse is now. So we know that the opposite segment from the 90 degree. Okay, that is AO is my hypotenuse. Okay, so value of A dash O and OA is L now. So we are finding cos theta, which is nothing but A dash O upon L. So our target is to find out the A dash O, which is nothing but L cos theta. Okay, similarly we have the B dash. So we have to find out the value of B dash O now. So we are doing what? The value of OP minus this term B dash P. So we get B dash O now. Okay, so similarly we get the value of B dash O, which is nothing but, okay, this is also similarly value we get like L cos theta. Okay, but how we get that value? this is the combination. When we are finding that value. Here also we get that particular value, but we have to find out the term like BP, which is approximately equal to B dash P, which is nothing but we have the value like we have OP. Okay, so OP minus we are finding suppose BP. Okay, so which is approximately equal to B dash P. That means we have OP. So we are suppose you are finding this value, so we have to subtract this value from this OP. So we have minus term, that is B dash O here. So we get similarly we get value here, that is nothing but OP is nothing but our value is R, which is nothing but minus L cos theta. So here we get a value like L cos theta. That means we can rewrite this value like R plus L cos theta. So we have equation 1 here and we have equation 2 here. Okay, now let's start to find out the electric potential due to an electric dipole at point P now. Okay, let's start. So we have V is my electric potential value. V is my electric potential value now. So I am taking that term. So V, which is nothing but we know that 1 upon 4 pi epsilon, okay, not into Q upon R. Okay, this is my electric potential term. We can take that 1 upon 4 pi epsilon not here into Q upon R. So using this term here in this figure, we have minus Q and we have a plus Q charge at point A and at point B. So we are taking the value at point A, that is which is nothing but V1. So we have V1 value. So V1 which is equal to 1 upon 4 pi epsilon naught into Q. So this value becomes minus. So we have finding this term regarding to at point A. Okay, so charge at point A is minus Q. So therefore we get minus Q upon R. So here we are not taking the value of R, we are taking the value here is nothing but AP. Okay, similarly we are finding the value of at point B. So we get V2 which is equal to 1 upon 4 pi epsilon naught into, here is we have plus Q upon, we are taking the value of BP now. Okay, now put the value of V1. So V1 which is nothing but 1 upon 4 pi epsilon naught into, we can take that minus sign to this side, so value becomes Q upon, what is our value? Value of AP is nothing but R plus L cos theta. So similarly we get V2 which is nothing but it is 1 upon 4 pi epsilon naught into Q upon R minus L cos theta. So we have to find out the actual electric potential due to this dipole. So we have to add that both values. So V which is equal to V1 plus V2 now. So therefore I'll get, so V1 is nothing but minus 1 upon 4 pi epsilon naught into Q upon R plus L cos theta. Okay, and our second term, that is V2 which is nothing but 1 upon 4 pi epsilon naught into Q upon R minus L cos theta. Okay, so we are adding that value, we have to take some common part outside that. So we get minus 1 upon 4 pi epsilon naught, okay, in a bracket we get Q upon R plus L cos theta. Okay, we are taking suppose minus sign outside, so we get the some value which will be changed now. Right now we are writing the same value, so we get plus Q upon R minus L cos theta. We can take Q also, we have common, so we can take that outside, and we are using this minus sign here. So we get, suppose you are taking that is plus, we are considering this is my plus term. Okay, so Q upon 4 pi epsilon naught, so this minus side comes here, so value becomes 1 upon R minus L cos theta minus 1 upon R plus L cos theta. Now look, here we get the value. Suppose I am taking the minus sign inside this bracket and this value becomes plus, then when we are multiplying minus into this bracket, so all the terms will be changes, the sign will be changed now. So we get 1 upon, so here is plus, here we get minus, here is plus, we get minus, and here is minus, we get the plus now. So we are using this term, so we get a v which is nothing but, now look, our value becomes like v which is equal to q upon 4 pi epsilon naught into, in a bracket, q 1 upon r minus l cos theta minus 1 upon r plus l cos theta now. Okay, let's start. We have to solve this now. So we have to first of all solve this bracket. So we have to take a denominator base value equal, okay, when we are subtraction or adding, so we are multiplying this value, so we are multiplying this term to this term. Okay, now look here, we have a r is nothing but, suppose we are considering a, and b is nothing but we are considering the value which is l, excuses, l cos theta, then our value becomes like here, so a minus b into a plus b. From this equation we get r is our a and l cos theta is b. So in first case we have l a minus b, and in second case we get a plus b, because here is r plus l cos theta and here is r minus l cos theta. So we know that a minus b into a plus b is nothing but a square minus b square. Okay, so we are using this term here towards the denominator, so we get the value like q upon 4 pi epsilon naught into 1. So first of all we have to solve this denominator value, so we get r square minus l square cos square theta, because it is our a square minus b square term. Okay, so when we are multiplying this both, so we are multiplying this both also in a cross way. Okay, so we get r plus l cos theta minus of r minus l cos theta. So this minus sign is here from this here, so this minus side is our values minus sign. Now let's start to solve this value. So we get q upon 4 pi epsilon naught, which is nothing but, we have this value, look at the numerator, we have some values which will be get cancelled. Here is r, here is r. Okay, so here is plus r, look, when the minus sign multiplies to this bracket, so r becomes minus and l cos theta becomes plus, so value becomes r plus l cos theta minus r plus l cos theta. Okay, so r get cancelled, so we have l cos theta, that means it becomes 2l cos theta upon r square minus l square cos square theta. Okay, so remaining term is q upon 4 pi epsilon naught into, here we get 2l cos theta. Now we have 2l cos theta and denominator value is r square l square cos square theta. Now look at the figure. So in figure we have the value like whatever we get the value. Here look at the term l is ob, gives value a o also and ob also. From this figure we get that the r is very greater than from this value l, very greater. So we are considering that term, means we are considering our r is very greater than l now. Okay, so from this figure we get that particular value. Suppose we are considering r is very greater than l, that means the term like l square cos square theta becomes, we can say it will be neglect now. Okay, it will be neglect. And we have another term when we are considering here, what is our electric dipole? Our electric dipole is nothing but q into 2l. Look at the equation coming here, we have q here, we have 2l here, that means it is our electric dipole. We can write p. Okay, so we have both values, like we have first value like r which is very greater than l, and we have p which is nothing but q into 2l. We are taking that both terms, so our equation becomes q upon 4 pi epsilon naught into p, okay sorry, 1 upon 4 pi epsilon naught, we are taking Q into L is nothing but P. So P cos theta upon, so L is very very small, or we can say R is very very great, and so this term is becomes neglecting, so we get only R square. Okay, so we are finding the electric potential V, which is nothing but 1 upon 4 pi epsilon naught P cos theta upon R square now. So we have two cases here, in which suppose we are considering in a first case our theta, in a first case our theta suppose we are considering 0, so we know that cos 0, which is nothing but 1, so our value becomes V, which is equal to 1 upon 4 pi epsilon naught P upon R square. So when we are considering our theta is 0, so electric potential due to the dipole, electric dipole, is nothing but 1 upon 4 pi epsilon into P upon R square. Suppose we are considering our theta, which is nothing but 180. So theta, which is nothing but 180, so cos 180 becomes minus 1. So our value becomes, using this term in equation, actual equation, suppose we are considering this equation is star now, we are putting this value, so V, which is equal to 1 upon 4, V, which is equal to 1 upon 4 pi epsilon naught P upon R square as it is. Why? Because there is 1. Look at the sign is minus, so we are taking V, which is nothing but minus 1 upon 4 pi epsilon naught into P upon R square. Therefore we have theta 180. If we have theta 0, then in that case our value becomes V, which is equal to plus minus 1 upon 4 pi epsilon naught into P upon R square. Suppose we have a theta which is nothing but 90 degree. Okay, we have theta 0, we have 180, means we have, suppose we are considering theta which is in a second case theta which is nothing but 90 degree. So we know that cos 90 is nothing but 0. So our V, which is nothing but 1 upon 4 pi epsilon naught into P into 0 upon R square. So this term becomes 0. So whenever there is a 90 degree theta, so we have the value which is nothing but 0. Okay, so today we are study about the electric potential due to an electric dipole. Thank you.